Good evening, class. I'm excited for tonight's homework lesson because we are starting a brand new module. And in this module 6, we are taking what we've been learning about fractions and place value and applying that to decimals. So we are going to start tonight in lesson 1 using metric measurement so that we can decompose one whole into tenths. So tenths is the first decimal notation that we are going to be working with. Now in this image we see a scale with some bags of rice on it, and what I want to call your attention to is that the weight of all this rice is 1 kilogram, and I know it's kilograms because my scale has the unit measurement there. So altogether this is 1 kilogram of rice. Now that kilogram is made up of several different sacks. To be precise, we have a total of 10 sacks of rice that make up this kilogram. So if I wanted to model this drawing a tape diagram, I could draw my one whole. This whole thing is 1 kilogram, and because it is made up of 10 sacks, I am going to divide this into tenths. And ask yourself, what fractional part of a kilogram is each of these sacks of rice? So since there are 10 equal parts, each sack represents 1/10. So we can add 1/10 plus 1/10, and we can keep going on our whole tape diagram. So 1 sack of rice is worth 1/10 kilogram. Now we've also earlier in the year learned about place value, and we had our place value chart with ones, tens, and hundreds. And then we talked about the fact that there would be a whole series going this direction on the number line of ways to write numbers that are smaller than 1 whole. So we've already learned how to write numbers smaller than 1 whole by using fractions. Now we're going to turn that into decimals. So just to the right of our ones place value, on the place value chart, this is going to be the tenths. And that represents our fractions, just like we have here, of 1/10. So this whole sack of rice, if we were to write it on the place value chart, would just be 1 kilogram. It'd go into the ones place because it's 1 whole. But if we were to take all these sacks of rice off and leave only this, then our measurement would change. It would no longer be 1 kilogram. It would be 1/10, and we would need to write that decimal there. So the fraction 1/10 can be written as the decimal 1/10. So it has that digit 1 in the tenths place. If we had 2 sacks of rice on the scale, then instead of saying that this is 1/10, we would simply switch that to 2/10. That's what those 2 sacks of rice on the scale would be, 2/10. If we were to put this on a number line, here we have a number line starting with 0. This is 1 whole, 1 decimal point 0, that's 1 whole. I can break this number line up into 10 equal parts. And I can label these with fractions. I can say this is 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10, and then all the way up to my 1 whole, which would be 10/10. Well, all of these can be rewritten as decimals. 1/10 is equal to 0.1. 2/10 is 0.2. 0.3. 0.4. 0.5. 0.6. 0.7. 0.8, and and 0.9. And we would read these the same way as we read the fraction: 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, and so on, because this digit is in the tenths place on our place value chart. So if I had the fraction 8/10, I could say that is equal to the decimal 8/10. If I had the fraction 2/10, I would say that is equal to the decimal 2/10. So here we have a number line. Again, we're starting with 0, ending at 1 whole. I have put some reference fractions on there for you and some decimal markers for you. Your quiz questions, I'm going to be asking you to identify the fraction and the decimal for point A, point B, and point C. So use the reference tools that you have, and again, there's 2 parts to each question. Write the number as a fraction and write the number as a decimal. The next thing we want to talk about is using our missing atom problems to figure out how many more to get to 1 whole. So here, if I have the fraction 8/10 centimeters plus some number of centimeters equals 1 whole centimeter, we would be able to figure that out. If we count up, we know that 10/10 centimeters would equal 1 whole. So if I already have 8/10, I would need 2/10 more centimeters in order to get to 1 whole centimeter. If we were writing this as a decimal, I would have 8/10 centimeters plus some number of centimeters equals 1 whole centimeter. If I already have 8/10, I can also think of this as dimes. Think of that as 80 cents. How many more cents would I need to get to that 1 whole? My answer as a decimal would be 2/10 centimeters. So for your quiz, 2/10 centimeters plus equals 1 centimeter. And then as a decimal, 2/10 centimeters plus what? Equals 1 centimeter. Six-tenths centimeters plus what? Equals 1 whole centimeter. And as a decimal. Okay, once you finish this Edpuzzle, you need to go back to Google Classroom, and there is a very short matching activity using a Google drawing. So please go back to Google Classroom, find that activity, and that is part 2 of your homework. Bring any questions you have back to class, and I will see you tomorrow morning. Have a great night.